look at it on an iPad or something like that rather than have physical papers. But I know, like, I mean, I could see for like an English teacher or something like that, they want to mark up on the paper because they're being nitpicky about grammar and stuff. I mean, I might take something off of a paragraph is like completely nonsensical, but if you miss a comma or something, I might not know you missed a comma. Okay, yeah, I'm a computer scientist, not I would have never gotten my dissertation written. When you get your PhD, you write this giant book. If my wife didn't edit that thing, they would have thought a 5-year-old wrote it. Yeah, I write well in terms of putting thoughts out, but when in doubt, add more commas, right? Apparently that's not a good rule of thumb.
NGs, words that end in ing, just gotta add a bunch of G's.
Well, I do that anyways. Yeah, when you don't know how to spell something, just purposely spell it very wrong, and they just assume you're like, oh, he's just being funny, not incompetent. Yeah, it's a good point.
I had a teacher in high school that when he would write on a whiteboard, he would only ever be able to read the first letter, and it was so that if he spelled a word wrong, you wouldn't know that he spelled a word wrong.
Oh, I gotcha. Yeah, I gotcha. So, yeah, so if I'm grading papers, I'm not nitpicking on grammar. I mean, if I run into this a lot in our grad program because the majority of our students in our MSCS is majority native English speakers, but MSIT, most of our students are Indian, Pakistani, Saudi students, and some of them are very well spoken, can write well, but as a general rule, their writing is their weak point. So you get a lot of humor out of reading some of these things. But if a paragraph is like completely nonsensical, I'll take off for that. But I'm not nitpicking, looking for grammar issues and stuff like that because why should I hold you to a standard I couldn't hold myself to, I guess. But I could see an English teacher wanting a hard copy of a paper so they can, kill it with red ink or whatever. So, but 800 pages is like plenty, right?
I think so.
Yeah, and what does it cost for extra? You don't know what an extra sheet costs? We got to put a value to this 800 find out how much we're saving this semester in terms of just raw dollars. Yeah, probably. Well, it's probably not much in reality. What is the markup? What are we actually charging? Is it a fair fee or is it an inflated fee? Yeah, like you go to the coffee shop here, you get we do Starbucks stuff or is it Starbucks here or is it something?
It's like fake Starbucks.
Right, but it's actually Starbucks coffee, right? Or is it another company? I think it's Starbucks. Yeah, so they have like basically it's Starbucks prices, right?
Yeah.
But it's not Starbucks professional baristas. Like the same thing as like sandwich artists at Subway. Right? Those people went to school to build that sandwich. Huh? High school. We did a boot camp this summer. I taught an iPhone programming course for like high school students here on campus. So it was 3 days, which by the way, I didn't get paid for. So maybe I should send the bill to the university, right? But in any case, one of the students there he works at Subway, and I was asking him about the sandwich artist thing, and apparently there's multiple levels of it. When you just have the sticker, you actually haven't attended sandwich artist school. You are in training. Yeah, they take it seriously. I think in the end, it's all about slicing tomatoes or something. Yeah, it's a skill. So all right, so quiz. What's a Boolean expression? Go ahead. Any expression that boils down to a single value of true or false. And then what's the difference between conditionals and loops? Maybe when would we use each? Something like that. Go ahead.
Well, conditional has to say pre-check loop, and the variable can be. It's something that's true and then it executes the body.
Okay. How many times does it execute the body? Once for a conditional. So conditional, if we're putting it in loop terms, a conditional would always be pre-check. We're asking a question, If the answer was true, we're performing an operation one time. Okay, a conditional allows us to ask one question. This goes back to this idea of how do human beings solve problems? Memory, asking questions, repetition. Conditionals are for asking questions. Loops are for repetition. We ask a question, we perform some operations, we ask the question again, potentially perform the operations again, so on and so forth until we finally fail the question. Make sense? All right, so conditionals are one-time potential execution of the body. Loops are potentially multiple executions of the body. If you wanted to go into pre-check loops, execute the body 0 or more times because we asked the question first, versus post-check loops, execute the body at least once, that's fine. I'm not necessarily looking for that in the quiz. I really wanted the distinction between asking a single question and responding to it accordingly versus asking a question potentially over and over again. You know, simulating repetition versus simulating asking a single question. I guess not simulating, emulating. See? Grammar thing. I don't know if I could spell either of those words. I think I could. I could spell both of those. Feel confident. Okay. And let's see. We didn't do anything else in Code Academy, but we did, half of the chapter in the book, right? Oh, that's right. I did, instead of 2 chapters, you had 1 chapter. That's right. That's right. So we're through chapter 3 in the book. Didn't I have a what did we do slide? All right, I'm going to add that. Progress book through chapter 3, and then Code Academy through section 2, right? Which is the branch stuff. Okay, fair enough. All right, so let's see where we left off here, and then I also want to do some actual programming today because we want to talk a little bit about command line. So just as a rehash, so last time we talked about loops, and here's your NG thing with a bunch of G's. So loops mimicking the way human beings repeat things. We have 3 different loops: for loops, while loops, do while loops. Each of them lend themselves to certain kind of classifications of problems. But that isn't to say that if you kind of have your favorite loop, you couldn't just use it to solve all looping problems. Because when there's a will, there's a way. With the correct number of if statements and stuff like that, you could make any of our loops solve any looping problem. But as a general rule, what kind of problem does a for loop lend itself to? Counting, yeah, when we know how many times we need to loop. Do something 10 times. Do something 5 times, that kind of stuff, okay? So for loops lend themselves to counting problems. What kind of problems do while loops lend themselves to? Okay, when we don't know the number of times, right? Now, both of these guys are pre-check loops. And what does it mean to be a pre-check loop? Go ahead. Oh, this will be exciting.
It checks first before it executes the loop to see if it needs to execute.
Okay, so we check before we do it even one time. Okay. I mean, it was an easy question, but you still, were above my expectations. All right. So now while loops are loops that are based on, they lend themselves to problems where we don't know how many times we need to loop. So for instance, while it's not raining, I'm going to mow the yard. So maybe we do a little weather check it'd be kind of obnoxious OCD if you're doing it every 5 seconds, but that's another use for the Apple Watch. If I'm outside mowing, I have an app called Dark Skies that's on my phone that gives you real time where you're at. It's rain is about to start in 5 minutes, that type of thing. So if I get the little haptic buzz on my watch and I say, oh, it's about to rain, I head in from mowing. I use a riding lawnmower, so I drive in from mowing. I love riding mowers, especially, it's not even mine. I steal my neighbor's.
It's relaxing, isn't it?
Well, I don't know if I'd say that, but yeah. No.
My wired in headphones.
Yeah. but relative to pushing a mower. Yeah. Although I always try to get too aggressive. We have a hill by my house. I keep thinking I could do one extra strip of that thing sideways. I got to take all the way to the left or that thing's rolling. All right. Then do-while loops. What kind of problems do do-while loops lend themselves to? Oh, you're here again. You're perfect attendance so far. Is that a goal for the semester? I think that's one of the situations you're supposed to lie to me. All right. What kind of problem does a do-while loop lend itself to? Go ahead. Yeah, where we have to do something at least one time, and the side effect of that is this guy is a post-check loop. We execute the body, then we ask the question. We execute the Boolean expression. And what was our example that we used for that? What's a good example of a problem that a do-while loop would lend itself to? Good. Authentication. Good. All right. So that's basically what we just talked about, those two things. All right. So now let's pause from new Java content for a minute. And let's talk about CLI. How many of you have seen those three letters before? Well, I know you've all seen those three letters. Have you seen them next to each other? I hope you've all seen those three letters. I glanced up at him just to make sure. These are all familiar letters to you?
I don't know, what's that middle one? I know it's in my name.
I just always thought it was a squiggle. All right, so this is command line interface. All right, so how many of you have ever had to interact with the command line interface? Some of you might not necessarily know what I'm talking about at this point. That's okay. Okay, what is it for? What did you do when you interacted with the command line interface? Tell me about that experience. What were you doing?
Well, I was doing it on a Raspberry Pi.
Okay. Already impressed? Okay, go ahead. Unless you're saying it was physically a raspberry. I was eating dessert. There was a Raspberry Pi.
There was just, I was downloading a different OS onto it. You
Okay.
could do that straight from the command line on there. You didn't have to create a new boot drive or anything.
Okay. So, a Raspberry Pi is like a little tiny computer. All right? And, you technically could hook them up to monitors and stuff like that. But in general, you typically have a Raspberry Pi either hooked up through USB or you're accessing it over like Wi-Fi. And in order to get to it, you remote into it. You connect into that Raspberry Pi. And what you're presented with is something that kind of looks like this. Okay? It's basically a Unix shell. All right? And you have to give it commands that particular command line interface understands. And that's how you make things happen. And this is instead of you moving a mouse around, double-clicking on crap, all that stuff. All right? This is the way it used to always work. Now, one thing that we kind of run into in today's world is we have this perception that this doesn't exist anymore. Okay? Where, well, you can see here, I use this a lot, right? Didn't even have to reopen. It was already open on my machine. So in many cases, command line interfaces are more powerful than what our applications let us do. And we'll see a piece of that in here. We won't see a whole lot of it, but we'll see a piece of it. Anybody else have any command line experience? Go ahead.
Basic things at work, printer, like stopping the spooler, starting the spooler.
Okay. So like remoting into routers, things like that. So effectively replace the Raspberry Pi with another piece of equipment. Here on campus, we have expensive routers. So, if you go to Best Buy and you buy a Linksys router for $30, they don't have a command line. Well, actually, you can get to a command line interface on it, but it's not advertised. They have you access it through a web page. They give you all the point and click stuff for doing that. But here on campus, they probably do have web interfaces now, but you know, the punchline is that they might just remote into that router and be using a, you know, a light version of Linux on it for managing that router. What about on Windows? If you're on a Windows machine, is there a command line interface on Windows? What is it? Command prompt, which is our modern version of what? DOS. So we go way, way, way back. Well, before Windows, when you bought a, you know, 386 computer, you know, an IBM 386, 25 megahertz. We've all had one of those, right? So a 386 SX, 25 megahertz processor with 1K of RAM. None of you have had one of those? A couple of you might have. You're a little older. What's the oldest computer you've had?
One I can remember would be had Windows 95 on it, so
Okay.
I don't remember anything before that.
Yeah, so Windows 95 would have been probably at least a DX2 66 megahertz something or other. Yeah. I'm getting old. I had a computer made by Epson. The printer people. That was an x86. I think it was a 12 megahertz processor with 32K of RAM. I promise you that did not have Windows on it. That was very much a sitting right next to it. We also had a electric typewriter. But it was the really fancy ones where you can like type a whole bunch, and it had like the single LCD screen, where before it actually, you know, put the ink to paper, you could edit the stuff and make it look right on a single line, and then say, okay, it looks good, fire, and it would, you know, it would put it all on paper. Oh man, it was awesome. Saved so much time having to do the whiteout stuff. Oh, plus it had the built-in whiteout when you hit backspace, the exact shape of the letter. How many of you have used a typewriter? Like at a museum or something? In high school, I had a typing class with, but it wasn't electric. They were mechanical typewriters where you really had to hit the key because the thing swung up and. All right, so if you're using DOS, what kind of stuff have you done with a command line interface in DOS on a Windows machine? Yeah, I'm saying historically you did everything from the command line in DOS. But if you're using Windows today, when might you need to go out to the command line? What kinds of stuff might you do out from the command line?
External hard drive that wouldn't, it would recognize it, but it wouldn't boot up. So I had to force it to actually like open up so I can get to the files.
Okay, so you had to maybe go out there and run like an Fdisk or you did a Google search and saw some command line stuff to try to fix the partition table or something like that.
And I went into there and it said, write this.
Yeah, right. So there are some applications that are available at the command line that we don't have an icon for to double click on, and there's no graphical user interface for it. So, one dealing with hard drives that comes to mind is probably Fdisk, which allows you to modify a partition table on a hard drive. But the punchline is there's still very much a use for these things, and in many cases, it's faster. See, we have this perception that because we're so used to using a mouse and to double click on stuff, that's the faster way of doing things. It's usually the easier way of doing things. You have to remember less stuff because it's all right there on the screen. Like, what do I want to do? I want to click that button right there because that button does the thing it's supposed to do. I run into that, all the time. If I just show you an example here, I'll just open up XCode. So this is a project that I'm working on for a client. So this is, XCode. Here's a whole bunch of different, so each one of these would be like a Java program, that go into this. But, I use these buttons up here all the time. I don't necessarily know what they're called until I hover over it. But this little circle guy, I know he's the guy I need when I'm an interface builder. I want code next to it. So what is he? The inspector view? Is that what it's called? Assistant editor. Assistant editor. All right. So GUIs are things that we've gotten used to using, and it sometimes makes our lives easier, but not necessarily faster. Make sense? All right. So I'm gonna kind of we're going to look at some commands for command line. We're just going to do a quick little crash course on basic commands. So this guy's command line interface, we have DOS and we have Unix. Those are our two command line interfaces that exist today. Well, yeah, we can say Unix/Linux, they're the same. So these guys are not necessarily compatible with each other, but they have some pretty similar things. They're related to each other. Let's say that. Now, the things that we need to be able to do in these is, change a directory, show a list of files in current directory. When you see a file called dot, that means this is a shortcut to this directory. Dot dot is a shortcut to the previous directory. So shortcut's one word, isn't it? Oh, that's a shortcut. That's not gonna. Boom, nailed it. All right, so just obviously there's a lot more to it than that, but let's just say those are some simple commands. Unix Linux side, cd, change directory, ls is a show a list of files in current directory, and then the dot dot stuff is the same. All right, so you can see they're pretty similar. Just instead of dir, we'll say ls if you're in Linux. So Linux, Unix, Mac, Macintosh operating system. It's not that Apple did something amazing. They built their OS on top of Unix. They didn't reinvent the wheel. They used the old wheel. Okay, so when we go out to the terminal here on a Mac, this is a Linux terminal, or it's actually an OpenBSD Unix terminal. The equivalent-ish thing on a Windows machine would be DOS. And you're going to have far, far, far more commands, tools available to you on a Mac than you would on DOS, because DOS has a very primitive set of things that are available to you because you have the Windows operating system sitting on top of it. Whereas what we're looking at here is still in many ways the entire operating system that people interface with when they're working with Linux. A lot of the time, it's faster to do stuff from out here than it is to start working with graphical user interface applications and things like that. So you have a much larger suite of built-in programs. So each of these guys are programs, CD, dir, that do something. Okay, but we have other things. So here here we have a who.java, so I can do more who.java, and this shows the contents of that. Similarly, I can do cat who.java, also shows the contents. The difference is more shows it one screen at a time. So if I had a whole bunch of stuff, in that, if that file was 1,000 pages long, it would show it to me one page at a time with the more command, as opposed to the cat command would just do a dump of the whole thing to the screen. You can do redirects and all sorts of stuff from the command line in Linux. So you can do pretty powerful stuff out here in Linux. Now, from our perspective, we're not going to have to do too much. I just kind of wanted to introduce you to this world. And where we're going to start off is we're going to write a simple little Java program. But instead of using Eclipse, like we saw last semester, because we were just kind of introducing Java and using some built-in stuff, we're going to do it completely from the command line. Okay, and just kind of see some of the tools that are available to us. If we were doing this in Windows, we would do edit, let's call this prog1.java, something like that, and that would open that up in Notepad. Historically, that would have opened it up in this blue background text editor on DOS. For the Mac, which is Linux, there are several different text editors we have to choose from, but the cool kids use VI. So we're going to say prog1.java. So VI is our text editor that we're going to use, and this is a very, very, very old text editor, and is when you first start using it, it's fairly intimidating. But it's actually built for touch typists, where your fingers never leave the keyboard. So you can do everything, saving, editing, deleting, all that stuff without ever taking your hands off the keyboard. So once you get used to the commands in it, you can do things pretty quickly. All right, so effectively we're editing a file called prog1.java. So it's going to look like this. All right, so just to kind of review some of the basic components. So first of all, when you hit escape, it's waiting for you to give it a mode instruction in VI. Now, let me preface this. I'm not going to expect you to be writing stuff in VI. This is more introducing you to what the tools look like, because especially when you get into like web programming and stuff like that, you actually do quite a bit more from the command line than you might think. All right. So I'll introduce you to the tools, but we are going to kind of see, we want to have an appreciation for what Eclipse is doing for us when we compile and run a Java program. All right, so I'm going to go into insert mode, which will allow me to actually type stuff. All right, and I'm going to go ahead and I'm going to say public class prog1. Put my opening and closing curly braces in there. And then public static void main string array args. Put my opening and closing curly brace in there. So already from the little work you've done with Eclipse, you already recognize things that Eclipse is doing for you. For instance, Eclipse, when you put an opening curly brace, it puts the matching closing curly brace. It does auto indentation. I'm having to do all that stuff manually. In Eclipse, if I created a new file called prog1.java, it would create the public class prog1. It would do all that for me. So it's filling in a lot of the gaps for you. And we'll go ahead and have this guy do our proverbial hello world program. Okay. Now, again, if I had an error in here, if I had forgotten the semicolon, Eclipse would give me a nice little red squiggly under there telling me something's not right. All right, so that's something else that's not happening in the kind of the old school tools of working with the programming languages. All right, so this should be a working hello world program. So just as a reminder here, forget about the word public for right now. We're going to talk about that in a lot more detail, but all programs begin and end with main. So this main method here has been around for a long time. Okay, it came from the C programming language, was still used in C++, Java, C#. Every programming language that's based off of C has a main method. Okay, and before we called it main, every program has a starting point, right? It's going to have its default starting point so that when you run that program, it has to go to some beginning point to start working. From there, it might branch off into other places in the program that you might write functions and things like this, but it's always going to start at some central point. All right, so we're starting in a method called main. Main must always look like this: public, static, void, and the word main. We're going to break this apart and talk about what each part means here, and then a parameter list. The parameter here must be a string array. You can name it whatever you want. So if you don't want to call it args, you can call it elephant or something like that. That doesn't matter. Okay, but we're going to kind of see what this means for us here in a minute. All right, so I'm going to go ahead, I'm going to run this program. Now, if we're in Eclipse, what do? We hit the little play button, right? And it magically runs. Well, here I'm going to have to compile it and then run it. So before I do that, I need to save the file first because all I'm in is a text editor. This guy doesn't know anything about Java. So I'm going to hit escape. Then I'm going to put a colon in and then WQ for write quit. And that saved the file. All right. So now I have a program, I have a program called prog1.java. If I cat prog1.java, you see the contents of it. All right. So now to compile a Java program, assuming you already have Java installed on the computer, so you've got it from Sun Microsystems. Macs come with Java pre-installed, at least an older version of Java pre-installed, so it'll do everything we need it to do from the command line here. To compile a Java program, we say javac, so that's Java compiler, and then the name of the program. All right. Go ahead and hit enter, and if everything was cool, it'll seem like nothing happened. Now when I do ls, let's just do prog1.star, it'll show me we have two files now. Okay, the second file is a file called prog1 class. Let me elevate that so you can see the stuff I'm doing a little bit higher up. All right, so this file right here was created as a result of me running this command, compiling that program. Now to actually run it, I'll do Java. This is calling the Java virtual machine, and then I'll say prog1. And there's our output, hello world. Make sense? Now if I want to go ahead and I want to introduce a bug into our program, so I've changed the code now. I need to compile it again. Compile it. It screams at me. Error, reached end of file while parsing. Closing curly brace. Okay. So it's giving me some sort of error message. So one of the skills we gain as a programmer is the ability to read error messages. Sometimes, so it's telling me it's on line 6, but whatever. Sometimes error messages will be clear. Sometimes error messages will talk about the error being here because that's when it was first noticed, but the actual problem was somewhere higher up in your program. Okay, so one of the skills that you'll gain as a programmer is going to be the skill of debugging programs. And this kind of goes back to this argument we've been talking about how programming is like a sport. All right, so you need to screw up a bunch of times in order to get better at stuff. You got to figure out what doesn't work, what does work, all sorts of stuff like that. So this is all part of the process. Now, one thing that a lot of beginning programmers do is when an error message pops up like this, they forget to read it. They just process that, oh, it doesn't work, and immediately just jump back in and start changing stuff. Okay? When sometimes the error messages are, well, I say sometimes, the error messages are always helpful. Sometimes they're more helpful than other times, but through experience, you will get better at reading an error message. Because there's going to be kind of that common group. I mean, while there might be 500 different error messages you might get, there's going to be a group of about 7 or 8 that you get often. And once you kind of get used to, like, oh, maybe you spend 2 hours hunting down a bug related to this error message, then like, oh, that's what that guy means. And then the next time you see it, you'll kind of say, oh, well, where did I do something related to that? Oh, right there. And then you can fix it pretty quickly because you went through that experience of kind of the hunting. Make sense? Sometimes bugs are more elusive than that. And it doesn't matter what level of programmer you are. You will run into bugs that aren't obvious at first. And you might spend a while hunting down those bugs. So as an example, last night I was working on actually the program I just showed you, that XCode one, was working on a program with a client. And so it's somebody I teach, so he's on a video chat and watches me code this project with him. And there was a part of it that was really slow. It was taking, it's hitting a database over the internet, so it's doing relatively complex stuff, but it was just taking a long time to do something. And that particular program has about 150,000 lines of code in it that we've written. So now we got to find out which chunk of that code is the code that's slow. So we start learning about using the debugger, putting breakpoints, and we'll talk about all this stuff, but basically narrowing down the part of the program out of all those lines of code that's actually the problem. Now you can probably make an initial guess, so you're not just looking at a needle in a haystack. You're really looking for a needle in a drawer. So you kind of know it's one of these three files is where the problem is in, and then you start putting, kind of narrowing it down. You're playing Sherlock Holmes until you finally get to a point where when you put a breakpoint before this chunk of code and you put a stop after this chunk of code and you run the program till it gets here, and then you say, okay, you hit play and you let it run from here to here, and it takes a long time, you know that your problem is in there. Now we need to look at this chunk of code and figure out what about that is being slow and start debugging from there. So sometimes errors are not syntax errors. They are performance-related errors, or you're doing something in an inefficient way that a human being actually notices. That makes sense? Now, computers are really, 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 really fast compared to us. So most of the time, we can write code in the most inefficient, correct way that we want, and we won't notice the difference because they're fast. All right. So with that in mind, we don't need to be too conscious of, or I guess let's say, we don't need to be too picky about writing efficient code. Especially as beginning programmers, I think you should always default to writing clear code, code that makes sense to you. If you could do something in 1 or 2 lines, but it makes more sense to you to do it in 4 or 5 lines, store this value in this variable, this value in this variable, this value in this variable, then do something with those 3 variables, do it that way. Do it in the way that makes sense to you. Don't say, well, I technically don't need this variable. I could just do all this in one scary looking line. Fine, nobody's impressed. Okay? When you take the computer architecture course and we start looking at assembly language, you'll figure out that, at the end of the day, whether you wrote it in 5 lines or you wrote it in 1 line, the same stuff it gets created under the hood, or at least very similar stuff. Make sense? Right? So nobody's going to be impressed if you can do stuff in less lines. So maybe our punchline there is that good programming doesn't mean less lines of code. One thing that good programming I think does mean, though, is easy to read code. So, for instance, Java does not care if I put this entire program all on 1 line. Java is completely cool with that. But that would be very difficult for a human being to read, right? So when we look at this, it looks, as far as stereo instructions can look, easy to read. Right? We have things indented. Once you kind of get used to searching for the various parts of a program, we figure that we can find those things pretty easily here. Make sense? One thing that you'll see in textbooks, and I'm sure our book does this, is you will sometimes see examples like this, where they put the opening curly brace on the same line as the other stuff. Yeah. My opinion is this is harder to read. What's your opinion? Is this harder to read? Easier to read? The same? Yeah, I do suspect that if you got used to looking at it this way, this isn't like a deal breaker, right? This doesn't make the world either become simple or very complex. But I find this to be substantially harder to read than having the curly braces immediately under the section that it belongs to.
I think the difference would come if you've got like 100 lines of code versus having these 3, where if you have 100 and all back together, it would be a lot more harder.
Okay. Yeah, and also then it's going to also depend on, so if you take that argument where you have 100 lines of code where maybe it all doesn't fit on the screen at once, one of the things I like about having the opening curly brace here and the corresponding closing curly brace here is you can see where it begins and ends. And you can line those things up, because a common problem that programmers make, and this goes, this kind of goes back to the comment I made earlier in class about, when in doubt, add commas. The programmer equivalent of that is when in doubt, add curly braces. All right, so never have too many curly braces. That's actually not true. You can have too many curly braces. So what ends up happening is if you haven't indented your code properly like this, you might end up having a missing curly brace or too many curly braces and not be able to see it. Proper indentation, at a glance, you would be able to see, oh, I have two closing curly braces here that are at the same indentation level. Something is likely wrong there, especially if that's in Eclipse that's doing auto indentation for you. If it thinks that those two guys should be at the same indentation level, there may be a problem. Okay? Or you've pasted some code in and you need to go through the process of telling Eclipse to re-indent. All right, so things like that I think become more obvious when you have your code written a certain way. But like I said, Java doesn't care. You can put your entire program on one line and Java will be perfectly happy. Okay, human beings will not be happy, but all right, so I guess whatever. That's the punchline there. Okay, so let's leave it at that for right now. All right, so when I come out here and I compile this program, what do I mean by compiling a program? So we're seeing the individual steps that happens when we're in Eclipse and we hit the play button, it's doing this. It's compiling and then it's running. It's doing those two steps under the hood for us, all from that single click the play button move. All right, what does it mean to compile a Java program? And this goes back to early in the semester, last semester, when we talked about, we had all those slides that, there are two different kinds of programming languages. There are three different, remember those? Okay, so we had compiled versus interpreted languages, which was one of those slides. What does it mean to compile a program?
Convert it from like a high level to a low level.
Okay. Convert a high-level language to a low-level language. Okay? So, what do you suspect my follow-up question is? What's a high-level language and what's a low-level language? What are those guys? Somebody else. Go ahead.
Low-level language is a language the computer understands the one and zero.
Okay.
While the high-level language is the one the programmer and the user will be able to interpret or understand.
Okay. Those aren't horrible initial definitions. I think we can get more distinct about it, but effectively you're saying a high-level language is something that's going to make more sense to people. A low-level language is going to be something that makes more sense to computers. True statement. That is true. We can get a little more granular with it than that. Go ahead.
High-level languages like Java, and we translate the Java code into the computer code 0, 0, 1, 0.
Okay. So true. Another true statement. Java is an example of a high-level language. I might, just as part of this argument, I might correct us in saying, so when we say zeros and ones, that is not a low-level language. Zeros and ones is machine language. In the right light, with your glasses off and your eyes closed, you could probably call zeros and ones a low-level language. Okay, and that'll make sense to you here in a second when we actually define low-level language. But officially, there's three levels of languages: high-level, low-level, machine language. Our zeros and ones are the machine language. All right. So now you've given us an example of one of our high-level languages, Java. Other examples would be C, C++, C#, Swift, Objective-C, Python, Perl, PHP. Pretty much any language you've heard of is going to be a high-level language for the reason he pointed out. Languages we've heard of are probably languages that humans use. Okay? They're ones that make sense to us. All right, so those are high-level languages. But now we want to give kind of a definition to that high-level language. What is the differentiating factor between a high-level language and a low-level language? So here we'll say 3 types of programming languages. We'll do a throwback. So we have high-level, low-level, and machine language. All right, so now we want to know what's the differentiating factor specifically between low level and high level. We've already said 0s and 1s for this guy. Somebody else has to know, especially since a majority of you have had this class with had the class with me last semester, and obviously everything I say is gold, so it's all just ingrained in there, right? Go ahead.
Is it high level a one-to-many relationship with CPU?
Yep. Yeah, one-to-many relationship with the CPU. This is a 1-to-1 relationship with the CPU. Okay, what does that mean? So he's recalled the correct slide. What does it mean to have a one-to-many relationship with the CPU? What's the CPU? I don't want to spend too long on the CPU, but because we did it last semester and we deal with that in great detail in some other courses. But what is the CPU of our computer? Ah, Lippmann terms, box of magic tricks. Love that. Okay, so this guy is a collection of magic tricks that each perform some, let's say, problem-solving task. Usually a very tiny task. The idea is that our CPU has this big collection of magic tricks, and each of those little magic tricks, each of those little programs made out of hardware, perform some tiny little task that when you put them together with other magic tricks, actually accomplishes something real. Okay? That's what our CPU is. Okay? Collection of magic tricks. Collection of, little tiny widgets that do something for us. Okay, so this is ultimately the guy that we're trying to speak to with our programming languages. When we write software, we're talking to this guy. All right. Now, as he pointed out, we kind of have a range of ways we can talk to our computer. We can talk to our computer with languages that are friendly to people, all the way to languages that are friendly to computers that are probably at the same time very unfriendly to people. So you would not want to just talk to a CPU with a stream of 0s and 1s. It's not going to be compatible with us. Make sense? All right, so we need to back off of that and say, well, what are our other options? All right, so when we look at a low-level language, this has a one-to-one relationship with the CPU. What I'm saying there is every line of code we write in a low-level language translates into exactly one of those magic tricks on the CPU. Okay, so we're still talking at a very granular level, okay, extremely granular level, but we're talking in a more English way than 0s and 1s. So it's understandable to humans relative to the 0s and 1s, but it's still difficult for us to work with. So an example of that in real life would be if you're telling me how to walk from here over to that door, okay? A high-level language, you might say, oh, we'll just walk to the end of this aisle, turn right, and walk to the door. Even though we know there's a whole bunch of stuff that's happening in the middle, right? A low-level language will say, lift your right leg, bend your right knee, fall forward, drop your right leg, apply power to all the muscles there, catch yourself. Getting the point? We haven't taken our first step yet, okay? And we're 4 or 5 instructions in, All right, if we think of us as a collection of magic tricks, all sorts of stuff we can do. We can bend at the elbow, we can move each individual finger. We have all sorts of muscles, some of which we have control over, some of which just things happen. All right, so if we think about us that way, it's a weird thing to pop up. That'd be really funny if I get somebody just throws some a bunch of cuss words or something up there. Not only is it in front of class, it's also recorded. But I've never cussed in my life, so it's not a problem. All right, so we kind of get the difference between a high level and low level. Okay, if we're using a low level language, an example of that would be assembly language. Okay, assembly language is a low level language that is way more Englishy than zeros and ones, so human beings can kind of work with it. But you're having to deal with that computer at an extremely granular level. So just, if you're making the translation here, imagine how used to working with human beings we are. Every one of us has a great level of, a great amount of experience with humans, right? We all kind of know about our joints and how our bodies work and things like that, right? So we have a lot of experience with that CPU. How long would it be until you got annoyed teaching me how to go from here to that door one joint at a time? And we're good at that, right? It would be annoying really quickly. Where with assembly language, it's even more granular. Or we'll just say it's the same level of granularity, but we're not good at that. Okay, we know humans way better than we know CPUs. All right, I've been doing this stuff for well over 20 years. I know humans better than I know CPUs because I've been doing the human thing longer than that. All right, so point is that at any level, you're going to kind of know people better than you're going to know computers. So it's going to get annoying real quick if we're dealing with people. You're going to be frustrated as anything if you're if you're having to talk to computers at the assembly language level, which we are going to do in 325. So that's fun stuff. So we as normal programmers, we like to use power tools. That's our high-level languages. We leverage something like Java, like C#, whatever. Pick your poison of high-level language. They're all doing the same thing. They're all giving us a power tool that allows us to say a lot of stuff in one statement. Walk to the end of this aisle. Turn right. Walk to the door. 3 little statements there had a whole bunch of inner meaning in it to a human being who was able to translate that down into all the little joint movements and things like that. Make sense? All right. All right, so compiling takes our high-level language, like Java, and converts it to a low-level language, like assembly. And then at runtime, we then translate that, we decode the assembly language into machine language. So that one very last step, when we run it through the virtual machine, Java space prog1, that guy, he's taking the Java bytecode, which is Java assembly language, let's say, and it's converting it into the equivalent machine language for the underlying CPU. Okay, now what do I mean by underlying CPU? Okay, Java runs inside of something called a virtual machine. What is that? What is a virtual machine? You don't even have to tell me about it in terms of Java specific. Just what's a virtual machine to begin with? Go ahead.
A computer within a computer.
Okay, fair enough. Computer within a computer. I'll take it a step further. It's a computer written in software. So we're emulating a physical computer through a software program that does all the things that that physical computer does, but through software. Okay, So, for example, some things that we may have dealt with virtual machines might have been, if you are a Mac user, you might have a program like VMware or Parallels that allows you to run Windows as an application on the Mac, right? So if you need to run both and you have enough horsepower, how many of you have ever run that on a Mac? Have run Parallels or VMware? Okay. What's the what was your experience? Good or bad? Okay, gotcha. So, any of you ever had a slow, sluggish experience with something like that? Typically, it'll get the job done. Really, you run into it on a laptop. If you have a laptop computer and you're trying to run, let's call it your average laptop, and you're trying to run VMware or a virtual machine, and you're trying to virtualize Windows while running the Mac OS, effectively, you're sharing all your system resources. So you're competing for hard drive access. You're sharing part of your memory. So you've basically dumbed down your Mac to give some resources to the PC, and neither of them really have enough to do a great job. All right, so things are typically sluggish. Now, where does a professional developer use this kind of tool? A lot of times web developers will do that so that they can test their applications on, because a lot of web developers are kind of Mac-centric people. It's kind of strange because even though I typically recommend to computer science students to get Macs, it's because it's 2 machines for the price of 1.7. Most, unless you're an iPhone programmer, most traditional programmers are going to be Windows people. You're going to do all your .NET development using Microsoft tools. You can do Android development on the Microsoft side, so you're not married to Mac for that. But it seems like web developers typically live on the Mac side. So kind of an interesting thing, I guess. But you're sharing all those resources. So when the web programmers, they typically will they'll virtualize Windows just for testing a website on like Internet Explorer or Edge now. Speaking of which, did Chrome fix your problem? Okay. Don't use Edge. Yeah, just leave it at that. Okay, so homework assignment, I'll put the topic up. You're going to write a 2 to 3 page paper on virtual machines. I'll give you some bullet points of things to focus on, and that will be due on Tuesday. And as far as the book goes, let's do chapter 4 through 4.11. So don't do the problems here. We'll look at those for next class. Okay? So read chapter 4, including the examples 4.10 and 4.11, which aren't programming assignments. They're things to look at. And then the paper that I'll post on online. Sound good? All right. I will see everybody on Tuesday.